This episode of Manufacturing the Future is brought to you by the Italian trade agency via its Machines Italia project.
Welcome to Manufacturing the Future. You know, we live in an age of robotics, and although humanoid, consumer-focused machines are everywhere in popular culture, the real sweet spot for robotic automation is in industrial and commercial applications. European firms are at the cutting edge of this technology, and a particular center of excellence is Italy, where advanced manufacturing robotics has been in daily use for decades. Like in America, the Italian auto industry were early adopters, and Turin-based COMAU has taken this experience and expanded into a wide range of machines and served industries that range from shipbuilding to packaging. Joining me to describe the capabilities of COMAU and Italian automation in general is Alejandro Alvarez, Business Development Manager North America for COMAU. Welcome to the program.
Thank you for having me, Jim.
Alejandro, in my introduction, I'd mentioned the fact that Italy is quite a center of excellence for robotic automation. COMAU has a long history in this field. Tell me a little bit about COMAU, how the history of the company, how you began with robotics.
Sure. COMAU has a history in Turin, as you mentioned, in Italy since 1973, when a group of Turin-based companies got together to do the first automotive assembly line. So if we see the history of COMAU, we are seeing a background in the body shops of the car since the 70s, where robots were building complete bodies using even automated guided vehicles to weld those bodies and then have a full product built by robots or hand built by robots, like it was said in that commercial in the 70s.
Yes, it's interesting to note in that the clip, the use of AGVs in the late 70s that's considerably in advance of most applications for AGVs. Only now are they really becoming popular in many aspects of manufacturing.
Exactly, yeah. But right now we see a new innovation, let's say. In the past, we were talking about automated guided vehicles. So they were following paths, they were following reflectors, they were following electric lines on the floor. And right now we're seeing autonomous mobile robots, which is something that COMAU is also working on. We're seeing robots that are able to move around the plant or the logistic facility on their own based on a map, similar to how you set up your vacuum cleaner at home, basically.
Yes. The vacuum cleaner at home, and many of us have this, I have one of these things, they're unique in that, as you say, they don't follow any specific pattern. They seem to move in random and erratic ways, but it's actually a very efficient way. So is this the sort of future we're looking at, do you think, with automation, where these machines sort of think their own way and do what they do, and we don't really understand how they do it?
Well, I mean, right now we are seeing actually the progress in this sense. So with these AMRs, automated mobile robots, we're seeing robots that are able to map the environment when you're installing them, and then you can draw a path to where they should go nominally, right? And then they will scan the environment for obstacles when doing the activities. The interesting thing is that these are autonomous vehicles. So if you think about even autonomous vehicles that we have been talking in these late years, right, with actually cars that drive themselves, is similar because they are guided by a fleet manager that avoids collisions between them, avoids traffic. They are using the robots in the best and most efficient way to do each of the activities. So we are seeing robots that for the eye of the human may not make sense which is doing which activity, but actually there's a software behind it optimizing which robot should be doing which activity, which robot should be charging, and how to avoid traffic in intersections, for example.
That's interesting because, of course, from a macro scale, they appear to be like ants in the anthill. They seem to be going in every direction, and you wonder how they don't collide or they don't get in the way of each other, but they don't. They seem to move smoothly through each other.
Exactly, and that's exactly the job of the fleet manager. Fleet manager job is to avoid collisions between them and to control traffic.
Now, the AGV, of course, is the mobile component of this. The robots themselves, robot arms, there's one moving smoothly behind you, in fact. They started historically in the early 1960s with Unimate in medium-duty applications, things like unloading injection molding machines or die casting machines. And the movement seems to have been in both directions. Machines have gotten larger for heavier applications, but also smaller for very precise applications in areas like electronics down there. What is the spectrum now in robotic automation? How big can they be? How small can they be?
Well, I mean, you said it right. Since the, let's say, 60s or 70s, where the robots were getting more popular, COMAU has been building robots in Italy since 1978, and we still do it. There's a huge range of robots from electronic assembly that can go, for a couple of kilograms of payload to large material handling that can go over 600 kilograms of payload. And they do different applications. They could be doing welding, arc welding, spot welding, palletizing. They could be doing measuring, inspection, many other activities also in the manufacturing world, like fastening or riveting, that are used for assembly. So the range is huge, and also the size of the robots can be really big. They can go from half a meter to or even 3.7 meters, which is, for example, our largest. And they can be used in different markets as well, because you mentioned, interestingly, in the 60s and 70s, there is something that drives the application of robotics, which is not only productivity, of course, it's also safety. And the use of robotics was also driven by the fact that there were a lot of operators doing repetitive tasks. And when you're doing repetitive tasks, apart from getting tired, you also get distracted. So isn't for a human, of course. So a robot doesn't have this problem, right? It's programmed to do it. And let's say that the most popular application at the beginning were very dangerous ones. For example, press-to-press applications, in which you're moving metal sheets from a press to the other, which are really dangerous for a person if it is distracted. Obviously, today, with the safety standards and norms, there are, for example, double acceptance to move the press up and down. There is laser scanners and light barriers, which are important, but there's nothing better than using a robot for an application that can be very repetitive and also very fast. I have seen applications, for example, in the general industry, like home appliances, where they need to use presses and move a piece to the other press in less than 8 seconds. That's something that, our operator has a difficulty of doing the whole day. And then we can open another topic, James, which is what happens when an operator is doing this for so long. Then you start getting musculoskeletal diseases. Those conditions and work where your muscles are getting tired, your joints get tired. And then also, if we want to also explore this topic, COMAU has worked on our technology speaks human. That's our lemma right now. So we are saying, not only we can use robots in the industry, but we can also enhance operators using wearable robotics to reduce the chance or the probability of getting injured from these disorders of the muscular system.
Now, that's a very interesting topic, and I want to loop back to that use of it to enhance human capability at the same time. Yes, in the factory, on the shop floor, you've seen it, I've seen it firsthand. Repetitive strain injuries are a major source of lost time, lost hours on the job, and a source of considerable pain and discomfort for workers, which nobody wants, either from a productivity standpoint or just a human, worker relations standpoint. Some of these machines you mentioned they can carry up to 600 kilos. That would be the weight of an entire body in white, for example, on automotive assembly line. But what sort of industries are typical users of your equipment? Because you've mentioned a huge range of very large, heavy lift machines, very small, precise, accurate machines. Which industries in particular are featured?
Well, historically, COMAU has been very active in the automotive field. So we see full body shops. That's what the industry calls body in white. It's when we are actually welding the initial metal sheets together. So that was the early adopter of this large scale automation. But then automation started expanding, and also COMAU is in the process of expanding its markets towards warehouse and logistics, which means material handling, boxes, bags, moving postal, type of elements. Or you can also be talking about a warehouse saving spare parts for vehicles or spare parts for any other equipment. We see automation also in the food industry. We see warehousing for supermarkets, where also we can see actually touching food and manipulating food to place it in bags, place chocolates on boxes. We can see it in the pharmaceutical industry by also moving vials, counting pills. It can be many different things where robotics is applied. Right now, it's very big to work in the battery manufacturing world, in which we call the e-mobility, right? electrical mobility is not only limited to the automobile, but it's also in ships, in airplanes, in energy storage for towns, actually also. And there's also a push right now to find robotics in a heavy industry. So weld very large pieces that require more advanced vision systems, or a system able to adapt to a piece that may not be exactly the one that you saw in the 3D CAD, in the CAD model. It's a piece that obviously suffers from the fact that it's so big that also bends, and its shapes is not as repetitive. So you need cells that are able to track, for example, welding seams, understand where the piece is. So you need to use vision system to understand where it is actually. And then we are seeing also growth in unstructured environments. So an unstructured environment is most probably an environment which is full of variation. It's where everything is different every time. Everything is located in a different way. Maybe lighting is not that constant. We're talking about also outdoor applications. We're talking about applications in which the part cannot be defined previously. It has to be learned while doing, and that requires understanding vision systems, finding parts, understanding where the features, for example, welding seams are, to actually do the assembly. So we see robotics across multiple sectors today, and there's a push to bring it to more.
Alejandro, you mentioned a wide variety of sectors. The needs are substantially different, not just the size or the mass that the robot handles. The pharmaceutical industry, the food industry, for example, sterility is a question. Do you have an environment where you must be able to clean or wash the equipment? And wash down environments are a challenge for every machine maker. You mentioned warehouse automation, package delivery, the Amazons of the world. There are challenges, an incredible variety of different sizes and shapes of objects that must be picked up and carried and manipulated, and the difficulties in that. Then you mentioned very, very large, heavy applications. If you're shipbuilding, for example, at that point, and you're welding plates or something along those lines, then that's a situation where the tolerances are very different from, say, the electronics industry, where it's almost micron level movement in there. Is there such thing as a universal robot that works for each of these applications, or do you custom build or custom specify specific machines for those sort of types of environments?
So, of course, there is a standard robotics part of the portfolio that all have different repeatability. So normally, as a rule of thumb, if you think about it, shorter robots, so with shorter reach, tend to have better repeatability. So they can be, when we talk about repeatability in the industry, we're talking about the ability of a robot to come back to the same point. Okay, so that is required in assemblies, very small assemblies like the one you were mentioning, electronics. We're talking about a repeatability of in the order of 50 micrometers, or maybe a bit less, 30 for very short robots. And when we're talking about palletizing, probably the application is bigger. So we're talking about big boxes, heavy loads, and in that case, the robot is less repeatable, but it has a way bigger payload and reach. So, physics, it tells you that if you have a very long arm, you're probably going to have some, apart from inertia, we also have the torque of the piece on the end of the robot, which is called the end effector, that bends also the robot itself. So it's a bit harder for the robot to be as repeatable as a very short robot doing small applications. Of course, you cannot palletize with a very short robot, because then you will be building a very, very tiny pallet. So there's no such thing as a generic machine for everything. It requires a minimum of customization, or let's say an analysis on which is the best equipment or machinery that should be used for that application. And if we talk about special projects or special applications, the ones like you mentioned in the shipbuilding, or the other one that COMAU has for solar panel installation outdoors, those type of application, they require customized machines. So they are machines made purposely to do that application only, because they require specific requirements, right? So, for example, for the shipbuilding that we were talking about a robot that is able to move, with wheels, or let's say with the with a radio control system that allows an operator to move this robot to teach him where the weld seams of the ship are. So by teaching where the weld seams are in the boat, then the robot can repeat them. So it's learning by teaching. So this is very interesting because it's a use of a vision system to follow a marker that then can be repeated by the robot using also other techniques, which are called, for example, weld seam tracking, which is using lasers, a sensor called profilometer, to follow precisely after you taught him how to do or where the weld seam is. Now he's able to follow the surface of that piece. So in that case, we're talking about specialized systems that were made especially for that application.
Yes, now that's an interesting concept. So it sounds like in the future, or perhaps even now, you can teach the robot to do the basic task, and then it refines its own motion based on what it sees.
Exactly, and we can see that if we think about collaborative robotics, which is a term that is being used a lot in the previous years. We're talking about robots that can work together with humans because they respect certain norms. So, for example, you're able to stop them by grabbing onto them, or and they use a lower speed to operate. For example, like my collaborative robot that I have behind me, that one it's able to work along me while I do this interview, exactly because it's respecting those safety standards. And in that case, that type of robot is able to be programmed by teaching. So before we mentioned teaching by following a marker with a vision system, but right now we can actually put this robot in a, let's call it manual guidance or flexible operation, in which I can actually grab onto it and move it, stop it, teach a point, move it by hand with my own arms, move it by hand, teach another point, and then tell the robot to repeat those. So that's a very, let's say, it's the newest and most advanced way to program easily a robot, even if you have never programmed one.
Alejandro, that's an interesting point, because historically, when a firm entered the realm of robotics, you had to train a special person who was the robot programmer. And perhaps he might be the only individual in the operation who had that knowledge, or one or two people, and they were very valuable. And the dream always was a machine in which it doesn't require special training to work up the M code necessary to program the thing. Is this a future? Are we looking at a future with especially collaborative robots where the assembly line worker may just stand next to the robot, reach over and show it manually how to do it, and that's the end of programming?
Oh, definitely. There are many ways of programming a robot today. Before, you were mentioning there's a specialized person that needs to know a very specific robot program language, because obviously every manufacturer invented their own language. And then what happened was the industry was so dispersed, so divided, that you had specialized people for every robot brand. But right now we are moving into an environment that is virtual, where you can program it in a CAD environment that has been used for the previous, let's say, 20 years. And now we are moving into a different way of programming, which can be graphical. You can use flowcharts to program a robot. You can use even in those flowchart commands, or let's say, commands or function blocks that are actually not related to the location where the robot should be, which was the typical way of programming, point by point, but now they are related to the task itself. You tell the robot, find this part, and then pick it, and then drop it somewhere over there after you have seen where the end location is. So that's task-based programming is also growing today, and COMAU is also part of a partnership that is trying to democratize robots into that sense. So democratize means more people can do it. You don't need now the specialized person that can program, the only person that can program it, like you said. Now, right now we're talking about anybody that can use a flowchart and follow a simple logic and now program a robot. And the manual guidance that I mentioned before is yet another way to get started with a very fast robot program draft, and then you can fine tune it, of course. So those are the type of things that we're seeing today. And beyond that, COMAU is also very engaged in the academy and education. So we have our own educational robot. It's called edu, and this edu, the most interesting thing is that we created a study plan basically to help students. We're talking about pupils, students from 10-year-old until 17, let's say, in school, that now they can learn about math, programming, and robotics in general by actually touching and using an educational robot. So they are learning how to do basic math if we're talking about young children, or they can learn about programming. They can learn about Python programming by programming a robot, or they can move a robot using the interface, so joint by joint, and they can get this, let's say, curiosity started. And we are then, in this case, supporting STEM, science, technology, engineering, math is something that we are supporting to have the next generation of robot programmers, which will not be the same as the current generation of robot programmers, because the next generation, they will be using more advanced systems. Right now we are building, like everything in programming is building on top, everything on top of what we already knew. So right now we are building programs based on vision system, based on AI, so systems that were trained to recognize boxes. For example, if we talk about depalletizing, which is something that we also offer, systems that can recognize any size of box, any location of the box, systems that can pick any item from a bin that have never seen before, systems that are trained to pick up boxes, pieces of a car, brackets, a banana. It can pick anything from a container. So, everything is getting more and more autonomous into what we call in COMAU cognitive robotics.
Alejandro, it's definitely the world is getting more autonomous from a machine perspective, but the ultimate form of collaborative robot may be a robot you can wear. And I understand that you have some technology there where literally wearables.
Exactly. Yeah, we were talking about that before. It's really interesting because that's the ultimate collaboration, if you think about it. So we're talking about a wearable device that you can wear, similar to a backpack, that you use it for very repetitive tasks in industry. So it will help your shoulders or lumbar area, so the back area, for example, lift from the ground, which is something that normally you should avoid in industry, but it still happens when you're doing manual palletizing. Because not always robotics will be exactly the answer, because sometimes it cannot be supported from a return of investment so quickly. But if you use wearable robotics, you can support your task force to reduce the chance of injury, or the absenteeism of the personnel. So there are two types of support: the shoulder support when you're doing assemblies, when you're lifting up your head, or the back support when you're doing, for example, manual palletizing. The markets where these exoskeletons are used are very varied. We're talking about post offices. We're talking about supermarkets, picking up fruit from trees. So we're talking about assembly lines in automotive, maintenance for airplanes, many applications, because the robot is not made for a specific market. The robot was made to support operators in muscular movements. So it's actually following your movement. It's a passive device. And passive devices are way better for working, Jim, because you are the one starting the movement. This robot will not weaken your muscles, which is different from active exoskeletons that can be seen in medicine. In medicine, for physiotherapy, you see active exoskeletons because they need to help you initiate movements. They need to help you learn how to do locomotion again. But in the passive, for right now, for assembly and manufacturing, we're talking about the reduction of muscle fibers that you are engaging to do a certain activity, right? So that will allow you to reduce the chance of injury at work.
Alejandro, the technology is fascinating. It is so broad. The thing that comes to mind immediately is Italian firm, Turin-based. Is in Italy, you have an engineering culture that goes back to the beginning of the Industrial Revolution, and we know the names. In electronics, Marconi founded an entire industry. Today, if I want a 150,000-ton ship, Fincantieri can build it. If I want a 200-kilogram fast motorcycle, I can purchase one from Moto Guzzi or Ducati. The biggest things, the smallest things, aircraft, spacecraft, all a wide variety of technology, all sort of based on Italy, largely in north of Italy. Is there something about having that wide spectrum of Italian customers and technology in a wide variety of industries? Has that been a reason for COMAU to base there and to build from there? Something about Italian engineering culture that works to your advantage?
Oh, it certainly is, like you're mentioning, because then we have the ability to create partnerships, find very high specialized suppliers. We also find customers interested in applying that technology. And that networking of Italian companies has also helped us to grow beyond Italy and go into the world and bring our technology also into similar markets somewhere else, right? So we're talking about collaborations for the robot that we're using for solar panel installation. We have a collaboration for the rover. We're talking about the collaboration with Incantieri when we talk about mobile welding. We are talking about a collaboration with the Italian post office, Poste Italiane, when we are talking about using the exoskeleton or other supermarkets in Italy. So there are many opportunities that we can use that can go even from the supplier that we use every day to do mechanical design, to do installation that are of great quality because we are using our, let's say, reputation and also network in the country as well.
Incredible. Alejandro Alvarez, Business Development Manager for COMAU. Thanks for joining me on the program.
Thank you very much for inviting me.
And thank you for watching. See you next time.